Hey guys, Mr. Mills is here. Today we're going to talk about compound inequalities again. But at the end of this video, you should be able to solve and graph OR inequalities. Okay, last lesson we talked about the first type of compound inequalities, the AND type, and today we're going to talk about the second type, the OR compound inequalities. Okay, so let's jump right into an example. First example says find a number greater than 10 or less than 3. So a number greater than 10, so we could say x is greater than 10, and a number less than 3, or a number less than 3, sorry. X is less than 3. So we put them together, we're going to say x is greater than 10, or x is less than 3. Notice that there's no special way of writing these inequalities. You can't have the word "or" in your answer. You always have the word "or" in your answer with OR compound inequalities. A solution to this type of compound inequality is a number that makes one inequality true. Okay, in the above example, there are no numbers that work for both inequalities. If you look at it, has to be a number that's greater than 10 and less than 3. So if you said 11, it would be greater than 10, but not less than 3. If you said 2, it would be less than 3, but not greater than 10. So for the OR inequalities, it's understood that only one of those requirements can be met. Okay, so no numbers work for both inequalities, but there are an infinite number of solutions to each inequality by itself. Infinite. Okay. To show all the solutions, we need to graph. Okay, so none of those rules change. Again, you're just graphing two graphs on the same, two lines on the same graph. And so we'll have x is greater than 10, here's 10, here's 3. They're both going to be open circles. Open circles greater than 10, less than 3. Okay. Okay. So here it says solve compound inequality, then show all the solutions. Okay, to solve these, simply solve each inequality, then combine the answers with the word OR. Okay, so I'm going to solve this left one here. 4x plus 3 is less than negative 5. I'll subtract 3 from both sides. Get 4x is less than negative 8. Divide by 4, and then we'll get x is less than negative 2. So x is less than negative 2. Solve the first one. Now I have to go to the second one. Subtract 7, so I have negative 2x is less than negative 6. Divide by negative 2. X is greater than 3. See, we divided by a negative number, so we have to flip our sign. Put the OR in the middle. There's my solution. And now I'm going to graph these values. Negative 2, 3, open circle, less than negative 2 goes this way, greater than 3 goes this way. And there's our solution. Okay. So basically with OR inequalities, you're really just solving two problems together. So AND inequalities kind of felt that way, like, hey, it's kind of like we're solving two inequalities. OR inequalities, you're definitely just solving two inequalities for the same problem. So let's look at another one here. I'm going to solve this left side first. 3x minus 2 is less than 4, less than or equal to 4. So I'm going to get x by itself. Add 2 on both sides. 6 is greater than or equal to 3x. Now divide by 3. 2 is greater than or equal to x. And so when I write this down, I always like to have my variables leading. So I have x is less than or equal to 2. Or, because if it started out as an OR inequality, it has to end as an OR inequality as well. So I'm going to solve the second one. Multiplying by 4, multiplying by 4. So I'll get 5x plus 2 is greater than 32. Subtract 2 from both sides. 5x is greater than 30. Divide by 5. We'll we'll get x is greater than 6. So we have, oops, not negative 2 there, it's positive. X is less than or equal to 2 or greater than 6. Alright, I will leave this number 2 for you. Okay, flipping to the back side, a couple more to do. So remember to do the number 2, that second inequality there. Okay, notice for number 3, this is an AND inequality. Just because we're talking about OR inequalities doesn't mean we can't do AND inequalities. So again, when we have an AND inequality, what we do to the middle, because we're trying to get x by itself, we'll do to every single side, and that's just the important part. Okay, negative 9 plus 1 will be 8. 31 plus 1 will be 32. Divide by 2 on both sides. And we'll get 4x 16. So we have x is greater than 4 and less than or equal to 16. So 4 here, 16 here, open circle, close circle, greater than 4, less than or equal to 16. There's our solution. Okay. Number 4. Again, we're just dealing with 2 separate inequalities here. So on this left side, a lot of people will want to distribute here. You can do that if you'd like to. I will choose just to get rid of this fraction. Okay, I'm going to do that by multiplying both sides by 3/2. Multiplying by the reciprocal. Okay, on this side it'll cancel out, so I'll be left with 3x plus 12. On this side I have 8. I'm going to write it up here so we can, down here so we can still see it. 8 times 3/2. So to do that I'm going to say 8 over 1 times 3 over 2 will be 24 over 2, which is just 12. Okay, makes it a lot easier. Now I'm going to subtract 12 from both sides. So 3x is less than or equal to 0. Divide by 3. So x is less than or equal to 0. Okay. Alright, now I'm going to go to the second part of the OR here. 2/3 x plus 12 equals 22. And so I'm going to try to get that by itself. I'll subtract 12 from both sides first. So 2/3 x is greater than or equal to 10. And now I'm going to multiply by the reciprocal. And I'll get x is greater than or equal to, remember that gives us 30 over 2 or 15. So, or x is greater than or equal to 15. So, both got 0 here, I've got 15 here. They're both or equal to's, so they're closed circles. So less than or equal to 0, greater than or equal to 15, and there we have it. Those are our solutions. So there you have OR inequalities, along with AND inequalities. So we have both of our compound inequalities kind of taken care of and out of the way. Remember with those that you're just solving and putting both graphs on the same, both lines on the same graph. All right, see ya.